Hello everyone, this is Namrata Rana, your chemistry educator on Chem with NR. Today we'll be learning about Riemer Tiemann reaction. I have listed down some important questions, previous year questions from Riemer Tiemann reaction. First question says that Riemer Tiemann reaction involves which of the intermediate? Just look for the terminology used, intermediate, right? Next is conversion of phenols to salicylaldehyde in presence of chloroform when reacted with aqueous NaOH involves which of the reaction mechanism. Second is asking about the type of mechanism it goes through. Third is IUPAC name of salicylaldehyde. This question is not particularly related to your Riemer Tiemann reaction, but yes, somehow it is related to it. Next is, which of the following is the correct representation of the Riemer Tiemann reaction? So, without any delay, let's begin. I hope if you keep on following the video, you will be able to attempt all the 4 questions by yourself. So, Riemer Tiemann reaction. Now, whenever you come across any name reaction in chemistry, just try to cut it into 4 parts. What do I mean by cut? Means you need to see 4 things. First is the reactant, right? Second is the product. Third is the reagent. And fourth is the mechanism. So, step by step, let's see what is the reactant which is used in Riemer Tiemann reaction. Reactant used is phenol. What is phenol? When benzene has OH group. This is your phenol. So, Riemer Tiemann reaction are the reactions particularly for phenols. Next is the product. That what is the final product a Riemer Tiemann reaction would form? It will form this phenol as it is and CHO group here. So there are 2 functional group in this. One is CHO, which is your aldehyde group. This is your aldehyde group and this is your phenolic group. So what is the name of this product? Now, preferentially, this is given the priority, and this OH becomes the substituted product, substituted reagent, right? So, name is benzaldehyde, but with OH group on second position. If you give this carbon number 1, this is your second position. So you can write 2-hydroxy benzene, or you can say is alpha hydroxy benzaldehyde, right? This is also known as salicylaldehyde. Salicylaldehyde is the another name for 2-hydroxy benzaldehyde. Right? Now, third is the reagent used. Reagent used is chloroform in this type of reaction. In Riemer Tiemann reaction, what we use? Chloroform in presence of aqueous alkali. Aqueous alkali, you can take NaOH. Right? This is your chloroform. CHLORO form. Now, let's see if there are any temperature condition or pressure condition. Yes, there are 70, temperature should be 60 to 70 degree Celsius. So this is the overall reaction. Now if I write the side product also, if I try to write the side product also, you will get 3 NaCl plus 2 molecules of water, right? And here we'll get 3 Na to balance the chemical equation. So overall, Riemer Tiemann reaction is the reaction of phenol to give us salicylaldehyde in presence of chloroform and aqueous NaOH at 60 to 70 degrees Celsius. This is the name reaction. Next, moving towards the mechanism of this reaction. Now, if I want to study the mechanism of Riemer Tiemann reaction, I'll categorize it into 2 steps. First is the formation of phenoxide ion. Formation of phenoxide ion. What is phenoxide ion? Now, if you consider the reaction, this is your phenolic part. You know, phenol has this acidic hydrogen. This hydrogen is acidic in nature. Why it is acidic in nature? Because as soon as H positive is released, you will get a phenoxide ion which is resonance stabilized, right? And this is a base. So simply there is an acid-base reaction to form phenoxide ion. So we'll consider this phenol part. This is my phenol part, OH. In presence of a base, in presence of NaOH, there is formation of this phenoxide double bond, alternate double bond in benzene ring with O negative, right? And H2O is released. Now, as soon as this phenoxide is formed, it is resonance stabilized. You can show the resonance like this. So, it will be somehow depicted like this, with a double bond oxygen and a negative charge on one of the carbon next to double bond as it is. As soon as you see this, it is a nucleophile, right? Because it has negative charge, right? Now, on nucleophile, there is always an attack of electrophile. So, to generate an electrophile, we need to take out the second step. First step was phenoxide ion, formation of phenoxide ion. Then, after phenoxide ion is formed, we have shown the resonance in phenoxide. This is resonating structure, one of the resonating structure of phenoxide ion, right? Second step is the formation of electrophile, which will attack on this resonating structure. Now you'll get this electrophile, generation of electrophile. I should say, second step is the generation of electrophile. Electrophile is, what is electrophile? It is actually in search of electrons. Any species which is in search of any electron is known as electrophile. Now, as you can see, you were given this. What is it? This is actually chloroform, right? CHLORO, chloroform. Now, chloroform in presence of NaOH, same reaction, acid-base reaction. What will happen is this H and this OH negative will form a H2O, and you will get, because this H will be replaced as H positive, right? So it has to be replaced by H positive. That means these electrons must be shifted towards this carbon atom. So we'll be getting a species like this. Cl, Cl and Cl as it is. Now if you see clearly, C is containing a negative charge which is unstable, right? So what can happen is you can remove one Cl negative from it. One Cl negative, as soon as this is removed, you will be getting a species which is known as dichlorocarbene. What is known as dichlorocarbene. Now, what is carbene? Carbene is actually one of the intermediate of carbon. Now, intermediate can be carbocation also, carboanion also, free radical also, and another intermediate is carbene. So, carbene is actually electron deficient. As you can see, electron deficient. As you can see, this carbon has only 6 electrons, right? 1, 2, 3, 4, 5 and 6. So 6 electron, that means it is electron deficient. It needs electrons. That is why it is, this is the reason it is acting like a electrophile. Also, it is neutral. This is neutral. This is electron deficient. It has 6 electron also. If I talk about the carbon is sp2 hybridized in this case, right? So this carbene is acting like a electrophile. As soon as this electrophile is generated, we will attack this electrophile on this resonating structure of phenoxide ion. So I'll write it separately, in which we had this from the first step. We had this from the first step, O with the negative charge on carbon here and double bond as it is. And in front of this CCl2. What is going to happen is this negative anion attacks the carbon to form a species of this kind. Now double bond as it is, this double bond as it is, this double bond oxygen as it is. Also, if you consider this structure, you also have a hydrogen here. So I am showing this hydrogen here and carbon here, which was having 2 Cl and Cl. Now, if you consider this carbon is electron deficient now also, because it has only 6 electrons in it, right? So, negative charge on carbon is unstable. Everybody knows that negative charge on carbon is unstable, right? Why? Because of the electronegativity of carbon. But negative charge on oxygen is somehow stable because of the higher electronegativity of oxygen. So this species is unstable. Another reason for the instability of this species is lack of aromaticity. See, there is no aromatic character in this ring. So to regain the aromatic character and to form a negative charge on oxygen, what happen is, see carefully please here, this H goes here between these two carbons. The electrons of this hydrogen goes between these two carbons. As soon as this carbon forms a double bond here, it will have 5 valencies, right? So this has to be shifted towards the oxygen, forming a species like this. If I make it again, you had this double bond, you already had this double bond. Now a double bond is here also, and oxygen single bond with a negative charge. As soon as this H positive is released, it is attacked by this carbon, right? So this carbon now has CHCl2. I hope this is clear, right? So as soon as this is formed, we treat this CHCl2 with 2 molecules of NaOH, 2 molecules of NaOH to form acid-base reaction. Cl will be substituted by 2 OH group. These 2 Cl would be substituted by OH and OH. We already had O negative here and a double bond here. As soon as this is formed, 2 OH group on the same carbon are unstable, so water has to be removed. So H2O has to be removed. So minus H2O will get C double bond O and H. Also here O negative double bond, this, like this. So I hope this is clear. O negative with CHO group on the alpha position means this had a relationship of 1:2. Now as soon as this is formed, you need to add H positive here and make it alcoholic part again with CHO, and benzene ring is formed, which is your salicylic, which is your salicylic. Fine. So this was the mechanism of Riemer Tiemann reaction. If I see it again, what I have done is I have converted the mechanism into two steps. First is the formation of phenoxide ion. As soon as this phenoxide ion is formed, it represents itself in this form, resonating structure, because I have to attack the electrophile on the carbon which is adjacent to the carbon containing this O group, right? Because it is alpha substitution of H by a CHO group, right? Then next is the next step is the generation of an electrophile. How electrophile is formed? By reaction of chloroform with aqueous alkali, which is NaOH in this case. As soon as this carbene is formed, everybody knows that carbene is electron deficient because it has 6 electrons. It is neutral species and the carbon is sp2 hybridized. This carbon is sp2 hybridized. As soon as these two compounds, which are depicted in these boxes, are formed, they react with each other. That is, there is electrophilic substitution, right? It is electrophilic substitution. The mechanism followed is electrophilic substitution. Why? Because this electrophile is substituting this H of the benzene ring. So, as soon as this CCl2 comes here, this compound lost its aromaticity. Also, carbon contains a negative charge, so it has to be shifted in this manner. Now, simple acid-base reaction where 2Cl group of the carbon will convert into 2OH group. As 2OH group on the same carbon are unstable, there is removal of water to form CHO group. CHO group, that is aldehyde group, and you need to add this H positive again so that you get the phenolic part again. So that was all in the mechanism of Riemann Tiemann reaction, right? I hope this is clear. Now let's try to do these 4 questions. The first question is, Riemann Tiemann reaction involve which of the intermediate? So it is very clear from the reaction that Riemann Tiemann reaction involves the intermediate, which was carbene, right? No carboanion was formed, carbonium ion was not formed, free radical were also not formed. So second question is conversion of phenol to salicylaldehyde. Now you need to depict it yourself that, okay, phenol is given and it is converting into salicylaldehyde. So yes, it is Riemann Tiemann reaction. In presence of chloroform, yes, now you are very sure that yes, chloroform and aqueous NaOH, it is 100% Riemann Tiemann reaction. So reaction mechanism, it is asking about the reaction mechanism. Free radical mechanism, no. Carbene was an intermediate. It was not a mechanism. It was not a type of mechanism. It is given to trick you, right? Carbene in Riemann Tiemann reaction is not mechanism. It is intermediate, which is taking part in the mechanism. So mechanism followed is electrophilic substitution, right? Now salicylaldehyde. Salicylaldehyde has a structure of when you have OH and CHO group at 1 and 2 position. So you need to prioritize the functional group. Functional group prioritization is this carbon because CHO group has to be given the priority. So CHO group on benzene is known as benzaldehyde, and this OH will become a substituent. So it is present at the second position. So you write 2-hydroxy benzaldehyde, right? Fourth question is, which of the following represents the correct Riemann Tiemann reaction? First is, we have phenol, yes. We have the chloroform, of course we have it, and alcoholic KOH. Now, NaOH. It was not alcoholic, it was actually aqueous form of NaOH. So this is not used because it is anhydrous AlCl3. This was not used because these were the reactions particularly for phenols. Here also it is not phenol, right? Last option is you have phenol, correct. You have chloroform, correct. You have aqueous NaOH. Can you tell me the product formed? Yes, of course, we have done it. This is simple Riemer Tiemann reaction. We'll write OH and we'll write CHO. So, fourth question. I hope all the 4 questions were very easy because of the mechanism and because of the reaction, right? Thank you so much.